All right. Hey there, guys. This is the first little foray into coding with our VEX IQ Clawbot drivetrain. The very basics of this program and how to get started a little bit. We're going to look today to write a program for for a path that we'll talk about in a few seconds here. But before we get to writing the path, we actually have to do a little bit of setting up so that we have the right pieces, right coding pieces to make this program happen. So the first thing you're going to need to do is open up your VEX programming Chrome extension, Chromebook extension. So if you haven't already installed it, there is a link in Classroom for putting that on your Chromebook. That link takes you right to the Chrome store so you can open it up. This program technically is not the same program that the one you're using. I'm on a computer, not a Chromebook, so we've got a little bit of difference. It should function the same way, and largely based on the little bit of information that I've done, that I've collected, it's going to function in largely the same way. So what we're going to do is we're going to start by making it so that our programming window understands what we've got set up for a robot. So in order to do that, we're going to come over here to this this little thing. I don't know. It looks like a microchip or something to me. It's that the second block or the second little button in the light blue banner. And it looks like what I'm pointing at right here. I don't know how to. So I'm going to click on that. And this is the devices menu, right? So with the devices menu open, we're going to click this add a device because we've got to add a device in order to be able to use it. And what we want to add specifically is a drivetrain. All right, we've got two motors in our drivetrain. We want to add a two-motor drivetrain. So we're going to click on this. And now the first thing it wants to know is what's the left motor on, and that should be port 1 for most of you. If it's not, we can talk about fixing this at some point, but it should be port 1. The right motor should be in port 6. And then the next question is it wants to know if you have a gyro. Now for you, this menu will look very much different, right? There's a little check box right underneath this for you that says gyro, and it's got a check mark. You want to deselect that check mark to make sure that we don't have a gyro set up. So right now, as our program is, we don't have a gyro set up, so we want no gyro. So I'm going to select no gyro from my menu. The next thing it looks at is things like the wheel size. Right now for you, I'm pretty sure the default wheel size will be 200 millimeters, which is what we're looking for. The wheels that we have on the robot right now are the 200 millimeter wheels. So that's a good sign. Track width, wheelbase, while that's important, it's not as important as everything else. So we're just going to leave it as it is. And once we've got all of this information checked out, we're going to click done. Okay. And that should get us some programming pieces that we're going to need. So let me get this back out of the way. I'm going to go ahead and hit the arrow here to make that go away because I've got what I want. So when we start this program, that's what this block says, when started. We want to be able to drive, obviously, because that's really what our goal is in this particular activity, is to be able to drive. So what we're going to do is check out the path, and that path is over here in challenge 1. So first I want to talk about what the expectations are. And so here's the program. You're going to program your robot to follow path 1, is what it should say. So that's definitely nice. Robot must end completely within a finish box. That's one requirement. The robot must remain at least partially above the travel line throughout its journey. The robot must in some way declare victory when it arrives. That's going to be a little bit different with this particular robot. And the program must include at least 4 different types of coding blocks. Now, a couple things. First, I call this challenge 1 stolen. And the reason I'm calling it challenge 1 stolen is because this actually was stolen from the Lego Mindstorm robotics stuff that we've done before. So some of you may have seen this before and be at least somewhat familiar with it. Here is a diagram of the path, and it's already got the measurements on it. Here's our start box. So we're going to start here. We want to travel forward 94 centimeters. Then we're going to turn 90 degrees, go forward 63 centimeters, turn 90 degrees, go 107 centimeters, turn 90 degrees, and go forward, I'll say another 63 centimeters, okay? That should end us in the finish box. Once we're there, we need to do something to declare victory. Yay, we did it, that kind of thing. So that's the program we need to run. If we go back to our VEX, what we're going to do is we're going to start by saying, okay, well, I want to start by driving forward. So drive forward, and we don't want to go 200 millimeters. So the first thing to do is look, okay, we only have millimeters and inches. So it's pretty simple to convert centimeters to millimeters. Keep in mind, all you have to do is multiply by 10, right? So if we want 94 centimeters, oopsies, 94 centimeters, that's going to be 940, 940 millimeters. So instead of 200, it's 940 millimeters. And once we've done that, what do we want to do? We want to turn right 90 degrees, right? And it should be a 90-degree turn, should be to the right. All those things are important. The next thing we're going to do is drive forward again, and then we'll turn right again, and then drive forward again, and turn right again, and drive forward. So all of that is pretty good, but we've got to get these numbers correct. So that the distance we're traveling is going to be important. So if we go back to, oopsies, that's my email, not my diagram. If we go back to our diagram, we went 94, now we're going 63, then 107. So let's go back here. So the next one is 630, right? 630 millimeters or 63 centimeters. And then we're looking at 107 centimeters or 1,070 millimeters, 1070 millimeters, and another 90-degree turn, and then the last move forward here is 63 centimeters. So 43 centimeters is the length of the line. Excuse me, 48 centimeters is the length of the line. So that would stop the robot right here, but we want to go into the box. The box is 31 centimeters total. Half of that is about 15 centimeters. 48 and 15 is about 63. So that should get us right about in the middle of the box. So 63 centimeters again, which is 630 millimeters. Now, that should end us up in the finished box. So this program should do the job. Keep in mind, though, if you take a look, we've got 2 different kinds of coding blocks. We need at least 4 different kinds of coding blocks. So what can we do? Well, we can do things like this. Print hello on the brain, right? That's pretty simple, right? We can, let's see what else we can do. Well, that's just about it. Yeah, that's pretty exciting. So let's put hello on the brain, and then we're going to do one other thing. We're going to do something beforehand. So we'll add some more blocks before. We're going to set the drive velocity. So that's how fast our robot's going to drive. And we'll also add a set turn velocity. So some of you like to go fast. So that would be 100% of the velocity. That's going to go as fast as it can. And then we'll keep the turn velocity at 50% because that way we won't go too fast. So right now we set our turn velocity, we set our drive velocity, then we did all that driving, and then we said hello at the end because we got there. Now you could change that hello to something other than hello, but whatever you've got a program. When you're done, I want a screenshot of your program submitted in the exit ticket. That's going to be how I know you've got a program written. But I'd also encourage you to name that program something else. So click right up here where it says VEX Code Project. Click there and name it something, right? So I'm going to name it square, a rectangle, path. That path was a rectangle, so there you go. I'm going to click save. That's nice. Yes, I would like to save here. I'm going to just save this in my downloads for now because that's going to be easier. And now I've got rectangle path saved as a program, and I can put that on my robot when I get back to school. And once it's on my robot, I should be able to drive that rectangular path without too much difficulty. Now, some students in my class the other day were starting to program with this VEX Code program. And they noticed that the 90-degree turns weren't going exactly 90. So that may be something that we need to adjust once we write this program, once we actually test the program out and see it's not turning exactly 90 degrees. Then we'll go back and adjust those turns. But for now, those 90-degree turns should be, we're assuming the robot's going to do what it's supposed to. We're assuming it's going to be a 90-degree turn. It should be. Okay. So again, screenshot and exit ticket of your program. Submit a screenshot of it, submit it in the exit ticket so that I can see the program you wrote. That's what we're looking for. That should do it. That's it, guys. Oh.